Another Leetcode problem 796 rotated string. So for this example, for this problem we are given two strings s and go. So we're going to return true if and only if s can become go after some number of shifts of the string s. So the meaning is the shift consists of moving the leftmost character of s to the rightmost position. So for example, if we are giving this a, b, c, d, e. So one of the shift we're gonna moving the rightmost e to the leftmost. So it's gonna become e, a, b, c, and d. Yeah. Or we can do it more about it. So we can also put a d here. Yeah. So there's no d. And then we can also put a c here, and then there's no c. So this is the meaning of the shift. So after some shift, we have the characters like c, d, e, a, b, and this is exactly the goal, c, d, e, a, b, and we're gonna return true. If we cannot find, so we're gonna return a false, like the example 2. So how can we make the shifts easily? As we can see from the examples, after shift, it's gonna be something like c, d, e, a, b, and after that it's gonna be b. So what if we just increase the string? Currently the length is n, so we increase it to 2 times n. So yeah, we just enlarge and increase the length of the string by 2. It's gonna be times 2. So if it's times 2, a, b, c, d, e, this is gonna be a, b, c, d, e. Yeah, so this is one of the normal ways to solve the problem. If we can increase the string s, double it by 2, so we're gonna find all the patterns for the shifting, the rightmost to the leftmost. Yeah, as you can say, a, b, c, d, e, b, c, d, e, a, and c, d, e, a, b, and we're gonna have all the patterns. And this one gonna be e, a, b, c, d, and the last one a, b, c, d, e. So this is a duplicate, but this is okay. Yeah, as we can see, by using this way, we're gonna find all the patterns by shifting the rightmost position to the leftmost position. Yeah. So the easiest way is that we can solve it directly. We're gonna prepare a string and pattern. So the string gonna be s times 2. The pattern gonna be the go. Yeah. So finally, we're gonna return if this pattern inside of the string. Yeah. But before that, we need to have a check if the length of the string not equal to the length of the go. So this means definitely it's a false. Otherwise, we're gonna check if it is inside. Yeah, because if the lengths are not equal, definitely it's not possible. Otherwise, we're gonna double it. Because after double it, we're gonna influence the length of the string. So this means before that, we have to check if the length equals or not. Now let me just submit it to check. As you can see, it works and it's pretty fast. Yeah, but for this problem, we are not going to solve it so easily like this, because basically this in, we're going to write some method for this in. In is a method in Python. We can solve it directly by using n plus n time. That is why it's so fast. So in is just a string matching, and we're going to use KMP to solve this method in. So how can we write this method in? So we're going to use the string matching, and we're going to use the KMP method. Yeah, so the KMP algorithm to solve the problem. Yeah. Now let me just remove this one and just to define a next table for the KMP function. So inside of the next table, I'm going to prepare a string s, and I'm going to do some preparations next and j. So the next is going to be a -1, going to be an array, and the first place I'm going to prepare a -1. This is just used for calculation, and similarly for the j. Yeah. And now let me just write the template. Yeah, because normally I already explained this problem in the template problem. So for this one, I don't want to explain why we're gonna write the next table like this. There are gonna be many different ways, but I think this one gonna be the easiest. So while j more than equal to 0, and si not equal to sj. Yeah, if it is not equal, so we're gonna jump j to the next one. It's gonna be the next table of j. So yeah, otherwise, if it is equal, so it means j gonna plus equal to 1, or if it didn't meet the condition, j gonna plus equal to 1, and the next gonna append this j. So finally we're gonna return the next array. Yeah. So this is the next table. Now we're gonna use this next table. So the next table we're gonna call this next method, and inside it's gonna be this string s, and we're gonna prepare a j gonna be starting from 0. Now we're gonna copy the same code to solve the problem. Yeah, because we just needed to check if there's some string inside. It's a string matrix. Now we're gonna check from here. Yeah, so this is our pattern. So this si gonna equal to this pattern p and j. Yeah, so if they are not equal, so j gonna equal to the next j. If they are equal, so this is j. Yeah, this is j gonna plus equal to 1. Maybe this is j gonna set inside of the next table. It's gonna set to 0, but it doesn't matter. So if they are not equal, so this is j might increase, because if this j equal to next j and next j gonna plus a 1, it's gonna increase. Yeah, so we just needed to check if this is j equal to the length of the pattern. So if it is equal, it's gonna be true. Otherwise, finally we're gonna return a false. Yeah. Now let me just run it and submit it to check if it works. Yeah, as you can see, it works and it's pretty fast like before. So this is exactly like when we write the in method in Python. So we're gonna use KMP. We're gonna prepare the next table, and continually we're gonna use some similar algorithm inside the next table to compare if we can find. If we can find, we're gonna directly return true. Otherwise, we're gonna return a false. Maybe I can use some examples to explain the next table. So here currently we have this pattern go A B C D E. So what it gonna looks like? Let me just print it out. What it gonna be looks like for the next table. Yeah, let me print it out the next. So as we can see from here, why it's so, yeah, it's gonna be the pattern, not the string. Let me first maybe use a string to explain. So inside of the first example, this is a string like ABCDE, double ABCDE. There's another ABCDE. So this is a 0 0. Now we have the suffix equal to the prefix. So this is why it is 1 2 3 4 5. Yeah. But what if we just use the pattern? So next gonna be the pattern. So as we can see, it's gonna be 0 0 0. Yeah, because it is the goal CD E A B, and there's no duplicate. So it's gonna always be 0. So this is why we're gonna use this next method to calculate the next table. Yeah, and after that we're gonna use the next table and together with the pattern S and P. Yeah, to find if there's a pattern inside. Yeah, I think that's all about it. Thank you for watching. See you next time.